future, we may see more cloud-enabled control, cloud-based control, distributed control, where the machine tool controllers don't actually sit at the machine anymore. Perhaps they are in some data center, and so if we want to upgrade the machine tool control system, all we have to do is update the software in the data center. We don't actually have to update each machine individually. That concludes my presentation, and I will now answer any questions.
Good, thank you. Okay, questions from the audience. Oh, Daniel, you're ready to roll, man.
Well, first of all, great job today, Roby. I've been really interested in your research ever since I had first learned about it in 2110. You know, actually, I'm not even sure if I'm going to be coming back for 2110 because, you know, the faculty for 2110 just love me too much, especially the good Dr. Telenko, of course. So my question is, what would you say are the long-term applications of this research? So what I'm thinking of is, like, what is the extent to which this research is applied? So is it something like you're more going to focus in, like, for educational purposes, like for research in academia and universities, or is it something that you're going to be doing, like, in a larger scale or bigger scale for, like, say, different applications in industry?
Well, I
Larger
think
than education?
I think actually we could look at both of those things. Personally, I'm most interested in the kind of industrial applications and specifically small parts, job shop type manufacturing where, let's say, you know, GE makes 20 billion turbine blades every year or something, and they have their program proven out, although it may not be very good. They may have it running and they don't want to change anything. It works, it makes us money, it's fine. But imagine a scenario where you're running a shop and you have all these new complex machines and you want to machine this particular part, and so you program it and it's not working right, and you don't have a huge staff of hundreds of manufacturing engineers to go back and tweak this and tweak that and tweak that. You really want to see within the CAM system what is going on in the machining process. Did it not follow this path exactly? How can I better control the machine to achieve better results on this part? So Sculpt Print, which is our voxel-based CAM system, really targets the kind of smaller production lot size because it allows for this easy user interface to plan 5-axis toolpaths without as much experience as would be required with typical CAM. So this is an extension of that to enable the control of the machine as well and not require a lot of people with a lot of experience to have to control the machine. So kind of that small scale industrial sector is what we're really going for, I think. But it could also be deployed in education too. So we have students, they don't know how to run machines. Maybe it's confusing for them when they have to create G code and then take it to the machine and run it. Wouldn't it be better if they could just control the machine directly from the CAM system and see the simulation while they're running? That would be a pretty good use case as well, I think.
Yeah, of course, I agree. And thank you. That was a really elegant answer to what I thought was a simple question.
Okay.
By the way, I think probably the biggest value is to somebody like a GE, because if they're going to make tens of thousands or hundreds of thousands of blades and they can get just that one little blade out of there.
That is true, right.
I mean, just a second savings is millions to them.
That is true.
So I think it's got applications across the board.
Okay, so just quick, whatever the word for a small story is here. So actually, Dr. Curtis has some anecdote, thank you. Has some students that work at GE machining blades, and one of the things that they have told us is that they don't even look at the MRR analysis when they're machining the blade. They just make the tool path, tweak it around, does this sound right? Which is kind of like how I run a machine now, by the way. Tweak it around, does this sound right? Yeah, go, it's making money. So, right, it could be very useful for them. They could see that we could be removing material in this part of the tool path faster, that part of the tool path faster. So, really, anywhere, yes.
Could you go to slide 28? I just had a question about how you're going to do something. Yeah, is that, 27, sorry.
Yes.
So the middle parts, the IO commands and position set points.
Mm-hmm.
So how do you foresee kind of transferring that? Is that part of the open architecture kind of stuff? Like if I were to do that with a Pocket CNC versus a Mazak, is that like the same kind of approach, whatever that is? Or?
So you actually can't access this level from any commercially available machine tool that I've ever heard of, unless you built the servo controllers yourself and you can talk to them over EtherCAT or something.